Okay, so question 8. The variable x has the distribution n. Oh, I should have opened the calculator already. X has the distribution n29. Find the probability that x is greater than 25. We're just going to do this on the calculator, aren't we? No messing with this. We're going to go into, how do you do it on the calculator? Distribution, normal, cumulative distribution. We want to find the probability that x is greater than 25. So on our calculator, oh, that's all wrong. On our calculator, we're going to do a lower bound of 25 because it's greater than that, an upper bound of some massive number. Sigma is going to be some amount, 3, and mu is 20, and if we press equals, we get an answer, 0.0478. 1 mark, because we're just doing it on the calculator, and there it is. There we are. Do we do a little copy of them? There it is. That's, yeah. Let's just do a little image of that, shall we? Right. Okay. Part B. Given that the probability of x being greater than a is 0.2, find a. Again, this we're just doing on our calculator. We're doing an inverse normal calculation on this, aren't we? So again, just the calculator. We're going to go back to that. We're going to do inverse normal. We're going to say that the area is. Oh, hang on. Do we need to turn this round? Is that right, or can we just do it? The area is 0.8. We'll do it that way. We've got the same values in there, and we get 22.5. 22.5. Yeah, so that's the probability that, using the probability that x is less than a is 0.8, and sticking that in the calculator because it only does the left-hand side in the calculator. So we have to turn it that way round. Part C. Given that the probability of x being between these two values is 0.5, we need to work out the values. Okay, so what we're going to do with this one, we're going to use the fact that the probability that's symmetrical, isn't it? If you think about what's going on with that, we're using that being there. There's a half in the middle, so they're the two values. 20 is the point in the middle, so we're B either side of that. So what we could say is that the probability that x is less than 20 plus b is 0.75 because there must be 0.25 at either side. So we'll go to our calculator again. We'll do the same kind of calculation with 0.75 in there and get a value of 22.023. So that gives that b is 2.02 to 3 significant figures. And there we are again. They allowed b equals 2 as the answer to that one. Right, now we're on to part D, and part D was a little bit more tricky. So the variable y has distribution mu squared over 9. Find the probability that y is greater than 1.5 mu. So we've got y is a normal distribution mu squared over 9, and the probability that y is greater than 1.5 times mu. And this is the bit where we do need to remember about that thing of the standards. standardising the normal distribution, the Z score and all of that kind of stuff that we looked at. So the way that mu appears all over the place in this is that if we were to standardise it, we would do 1.5 mu minus mu over the square root of mu squared over 9, so over mu over 3. And that would give us our standardised value for the standardised function. Now the advantage of that is that mu cancels out completely in all of that. So you end up with a half of mu divided by a third of mu, which is 3 over 2.
You get a mark for
You do get a mark for that.
that? I didn't get a mark for that.
Oh, you will get a mark for that. In fact, you actually get 2 marks for doing that bit of working out. So what this is actually saying is that we're now doing Z as being normal distributed with 0 and 1, and we want the probability that Z is greater than 1.5. Greater than 3 over 2. That's what we're after. And in our calculator, we can, I keep pressing the wrong thing, we can do that by doing a normal cumulative distribution, so that's 2. We want our lower bound to be 1.5, our upper bound to be some massive number. This time that is 1 and mu is 0. And we get an answer of 0.0668. There we go. It wasn't detailed reasoning, but what they did do in the mark scheme for this is that if you just picked a value for mu and tried to figure it out by picking some value for mu, they gave you 2 out of 3 marks if you got to the right answer. Because you hadn't quite kind of got the subtlety of the question, but you'd come up with the right answer. So it's one of those slightly unusual things where the right answer doesn't give you all the marks. If you just picked a value of mu, you ended up with 2 out of 3. You could have picked any value for mu because it was all independent of what mu was, because of the way it was constructed. There we go.